Okay, for your 1.9 homework help, I'm going to do a problem, I think it's problem number 24 from your homework. You don't actually have this problem due on your homework, but it's problem number 24 from your book. You've got 3 or 4 different problems that are like this. It's a trickier one in terms of finding the inverse. This one's just going to ask to show that they're inverses. So they're telling you that they are inverses. They just want you to show it. And like I said, I'll run through that one. It'll help you with 3 or 4 problems in your homework if you're having trouble with it. And then the other 2 that I'm going to do is they're going to give you a 2 function and ask you to find g inverse of f inverse of -3. And I'll do one that's similar to that. And that's, I believe, in the 70s when you get to your homework. Alright, so this first one, like I said, you're going to have 3 or 4 that are similar to this. Now this problem is not asking me to find the inverse, because like I said, they are actually telling you that those are inverses. They just want you to show it. Now technically what that means, when we did this in the notes, is that technically I should find f of g of x and show that it equals x. If it doesn't, they're not inverses, and obviously it has to because they told us that they were. And then after that, I have to find g of f of x and show that that would also simplify to x. Now that's technically what they want us to do. And yeah, we probably should do that, but we don't necessarily have to. If we know how to find an inverse, which we do, let's go ahead and just do that instead. Alright, so I'm going to take one of the functions, doesn't matter which one, and I'm just going to change this to a y since we know that's the same thing. Y is equal to x plus 3 over x minus 2. And I'm going to run through my steps to actually find the inverse. And like I said, this one's a little more tricky because, well, you're going to see I have more than one x, which means when I start solving, I'm going to end up with more than one y. So first step, I know I'm supposed to take all the y's, change them to x's, all the x's, change them to y's. So I am now going to have x is equal to y plus 3 over y minus 2. And now second step and last step is solve for y. So it sounds simple enough, but depending on the function, that could entail a lot more work. Solving for y, and I have more than one of them, and I notice one of them is in the denominator. Typically you have solving for something that's in the denominator, it's a good idea to cross multiply. So I'm going to multiply both sides by y minus 2. And then I'm going to go ahead and distribute or simplify this just a little bit. You're probably thinking, well, maybe if I divide by this quantity, I can get the y back over here. Well, then I'm just back to where I started with. So I'm going to go ahead and actually multiply out the x, which is what I suggest you do for any problem that looks like this. Alright, and now I want to solve this. And it's a linear equation. Obviously it's not like some of the other linear equations that we've dealt with, but if you take a look at something like this, 3x plus 1 is equal to 6x minus 9. That one's pretty simple. Yeah, we say, yeah, well, I know I'm supposed to move all the x's to one side, move all the other stuff to the other. Well, same idea. I'm solving for y. So move all the y's to one side, meaning I want these two terms on the same side. Doesn't matter if it's the right or the left. So I'm going to subtract y over to the left side, which gives me xy, and then like I said, I'm subtracting it. So now I've got, kind of like over here, I've got the x terms on the same side. Let's say I subtracted 3x. Well, now the idea is I would move that 9 over there instinctively. I know to do that. Well, what you're really doing is you're saying anything that doesn't have an x, move it to the other side. So now when I come down here, since I'm solving for y, anything that doesn't have a y on it, move it to the other side. So since I move these two to the left, I need to have those two on the right, which means I'm going to add 2x to the right side. And the reason I want to have all the terms with y on the same side is because that means they have y in common, and I can factor a y out. So I factor out y, that would leave me with an x and a minus 1, still equals 2x plus 3, and although this doesn't really look like this, same idea. I'm solving for y. Consider that to be just a quantity. It's like the 3. You divide by 3 to get rid of it. I want to divide by the x minus 1 to get rid of it. And now I have y is equal to 2x plus 3 over x minus 1. And then, of course, what we did is we switched it to the inverse. We said it was f inverse of x is equal to, or according to what they're saying, it's g of x is equal to 2x plus 3 minus 1. You can see that that's the same thing. So we have shown that they are inverses by actually getting better practice at finding inverses. That's what I would suggest that you do. Like I said, you'll have 2 or 3 problems that are like that, where you have an x in the numerator and denominator, and you'll have to cross multiply and do the same steps. Alright, so hopefully that'll help you with a few problems. So Second problem I'm going to do is, like I said, they're going to give you two random functions, and then they're going to ask you to just find a composition. Remember, like we did from 1.8, that this is the same thing. This is kind of how I like to write it, but it shouldn't matter. You should be able to recognize it either way. So when you see that little open circle, it doesn't mean that you're multiplying. If it was a closed circle or a dot, then yes, you're multiplying. Alright, so I need to know what F inverse is first so I can plug -3 in, and then I need to know what G inverse is. So I'm going to need the inverse of both of these things. So if I start with function F, I'm again going to switch X and Y around. Remember, that's Y. And then I'm going to try to solve for Y. So I'm going to, it doesn't matter if you add 3 first or multiply by 8, it won't make a difference. I'm going to go ahead and add 3 first. That's typically what we would do. And then I'm going to multiply both sides by 8. And just remember, since this is a quantity, you have to distribute that 8 to both terms. Now you can leave it like that. I prefer to simplify, so I'm going to say F inverse of X is equal to 8X plus 24. So there's the first inverse. Now I go for function G's inverse again. There's Y, so when I switch the X and Y around, I end up with this. X is equal to Y to the third. And nothing to add or divide or anything like that. I can just immediately go to taking the third root of both sides. So for this one, G inverse of X is going to equal the third root of X. Alright, and now according to what this is telling me to do, it's saying take -3 and plug it into F inverse first. So I can take -3 and plug it in here first, which is going to give me 8 times -3, or -24, plus 24. So this is actually going to give me 0. So I'm now looking at G inverse of 0. Again, just to remind you, I'm taking that number and plugging it into F inverse for X. And by doing that, I ended up with 0. Now it's going to ask me to take 0 and plug it into G inverse. Well, if I take 0 and I take the Q root of it, it's going to give me 0. And that would be my final answer. Not the only way to do that. Let's say that this was actually an X instead of an actual number. Then I don't have a number to plug in. Then it's kind of like what we did in 1.8. They want me to take function F inverse, which is this function here, and plug it into G inverse. So I would take this whole equation and I would plug it in for function X. And that's actually one of your homework problems. Alright, then the last problem I'll do is something similar to this one. It's given these two functions, find G inverse of 4. Realistically, there's no need to have function F here. We're not ever using it. Same type of problem, it's just you're going to plug it into the inverse twice. So clearly I need to know what the inverse of G is. So again, switch X and Y around so that you have X is equal to 2Y minus 5. In terms of the solving, you're going to go ahead and add 5 to both sides. Going to divide both sides by 2, and I always like putting the G inverse or Y or whatever it is on the left side. Doesn't matter which side you have it on. Divide by 2, I'm going to have X plus 5 over 2. Now, if you prefer to have 1/2 X plus 5 over 2, that's fine. They're the same thing. A lot of times when I see that neither of these fractions will simplify, a lot of time I'll leave it like this. So it's up to you. It's not my final answer, so it doesn't matter. If this was my final answer, was that, then typically I would break it apart and try to simplify, but it's not my final answer. So I'm going to use this for my inverse. It's asking me to plug 4 into G inverse. So if I plug 4 in here, I'm going to get 9 over 2. Well, let me rewrite this here for a second. Remember, this is kind of how I like to write it, but you should be able to use it both ways. I've plugged 4 into the inverse, and I got 9/2. So this is actually equal to 9/2. Now it wants me to take 9/2 and plug it into the inverse again. So that's going to give me 9 over 2 plus 5 over 2. And now you just have to go ahead and simplify. Going to want to get yourself a common denominator, so 10 over 2, which is going to give me 19 over 2 over 2. Remember that that's really 2 over 1, so when you multiply by the reciprocal, you're looking at 19/2 times 1/2. And that's going to eventually give you 19/4. And that would be your final answer. And again, I prefer that you leave them as improper fractions. Do simplify if you can, but for that particular one, we can't. Hopefully that'll help you out with your homework for section 1.9. Like always, if you have trouble, let me know.